We are Team Data Waves presenting a solution flowchart for SIH 2025. Argo Ocean data is a global treasure, but it is stored in complex NetCDF files. Accessing it requires coding expertise and weeks of training, making it difficult for policymakers, students, and even researchers to use efficiently. Now my teammate Lavish will continue on with the proposed solution.
Argo data is incredibly valuable but comes with challenges. It stores in NetCDF, which is not human readable. The volume is huge with over 20 years of profiles, and measurements are non-uniform across the flows. This creates a step learning curve for the students, researchers, and policymakers. Our solution is an AI powered dashboard that makes Argo data easy to explore. User can ask questions in plain English and get an instant outputs like maps, flow trajectories, depth profiles, and time series trends. Behind the scenes, we convert the NetCDF into PostSQL and use LLMs with retrieval augmented generation for query visualization. To make the platform more engaging, we are onboarding the new users with a quiz style module, especially useful for students. Beyond the point based analysis, users can also select a region on a map and get an average values. Most importantly, we will enhance the dataset by adding BGC Argo floats, which includes pH, dissolved oxygen, and other biochemical parameters.
So the technical implementation could be broadly classified into two sections. First is how we would pre-process the data, and second is how we would add a layer of LLM or RAG to it. So for the first stage, when we are fetching NetCDF format files from the Argo repository, they consist of millions of profiles and multidimensional information consisting of temperature, salinity, pressure, depth, etc. We can process them using Python libraries such as NetCDF4 and X-arrays, and then we can embed it using a sentence transformer models into vector databases such as FAIS or Chroma. Then, to add a level of sophistication, we could add a layer of RAG or LLM, which Nikhil would talk about.
So once the data is indexed in the vector database, we build a RAG pipeline. When a user enters a natural language questions, like suppose a user asks us what is the average temperature in the Indian Ocean in July. So the system would retrieve the relevant summaries from the vector store and pass them along with the query into the large language model. Let's suppose we are using Mistral or Wind. The LLM then generates a context-aware human-readable answer, which is actual Argo data. We also support visual outputs like temperature depth graphs, flow trajectories, which are rendered using Plotly or Streamlit. This entire pipeline from data to retrieval to intelligent answer generation makes Argo data accessible to non-expert through a simple conversation interface. Now, Yash should talk about feasibility.
Our solution is both technically and economically practical. Argo provides 25 plus years of open access data with 150,000 new profiles each year. Mature tools like X-Array and Pandas can process over 1,000 files per hour. Visualization frameworks like Folium, Plotly, and Streamlit are reliable in geospatial data. Now, Anushka will talk about impact and benefits.
Creates a strong impact by democratizing ocean data. Traditionally, Argo datasets require coding expertise and hours of pre-processing. With our AI-powered dashboard, policymakers, educators, and students can now access insights instantly in plain English. This leads to faster insights and better decisions. What once took days is now reduced to seconds, enabling timely responses to climate events. Fisheries, management, and coastal resilience planning are all benefited from this. Oceans also absorb most of the Earth's excess heat, and Argo data is central for tracking it. And our platform helps to strengthen climate models, IPCC reports, and the sustainability efforts. It also enhances education and public awareness. By turning complex data into interactive visuals, we make ocean science accessible to non-experts, building climate literacy and engaging the next generation. Most importantly, we expand beyond physical data by integrating BCG Argo floats, adding critical parameters such as pH, dissolved oxygen, and other chemical indicators. These additional layers provide a rich picture of ocean health, ecosystems, and the carbon cycle. In short, our solution bridges raw scientific data and actionable insights, making ocean intelligence accessible.